Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, the 4 superpowers of digital transformation with special guest Greg Ernst, Corporate VP of Sales in the Americas. Greg, welcome to the show.
Thank you, Darren. It's good to be on for my second show.
I know it's been, a year since you were on?
I think it is about once a year. Exactly.
Yeah, once a year you get to come on the show. Tell us how things are going.
Yeah, I get to, instead of listening, I get to actually speak. You've become, I tell my team all the time, I listen to this while I run. So it's been, thank you for the entertainment over the last 52 weeks.
Well, thank you. Thank you, Greg. I appreciate your support in helping me do this. Especially today, we're going to talk about Intel's 4 superpowers. They really tie into public sector. On my side, I talk about the 6 pillars of public sector transformation, and 4 of those pillars are the 4 superpowers. So great minds think alike.
Yeah, exactly. No coincidence. But as I've delved deeper and deeper into the public sector, it's just clear that so much of what on the pub sector side they're trying to solve regarding mission outcomes and how they do it, like you said, aligned to what our 4 superpowers are, that are very applicable to enterprises as well.
Yeah, so let's go over what those 4 superpowers are, because not everyone listens to every show. I know that. It's a shame. Everyone should, but they don't. Yeah. So let's talk about what those 4 superpowers are. And these are 4 areas that Intel is really focusing on. Above and beyond, they're not going to sound like silicon at all, are they?
No, they're not. And that's what it's, I mean, for me, it's these 4, I'll just list them real quick. The concept of ubiquitous compute is number 1. And this idea that it's really kind of a concept in software engineering where compute is pervasive and everywhere. So that would be number 1. Number 2 is pervasive connectivity, and it allows technology that's dispersed all over the world to communicate. Number 3 is this concept of really cloud to edge and extending your compute network as an enterprise or a public sector from cloud all the way to edge. And then 4th are AI, artificial intelligence, which allows businesses and agencies to take the billions and billions of bytes of data that get created each day and really extract actionable insights from them. So at a real basic level, those are the 4. And Darren, what I'm seeing is as we go out and we talk to companies or public agencies around their digital transformation strategy, there's elements of each 4 of these that's mandatory. It's an underpinning. And so it's what we're working on as a company and what all the businesses around the world are doing as part of digital transformation. Is that there's a great synergy there.
So let's talk first about pervasive compute. I mean, what really does that mean? Because you're saying ubiquitous, I guess, ubiquitous compute.
Yeah.
You're saying it's everywhere, which means what? I mean, we're talking smartwatches, smartphones, smart refrigerators now that tell me when my milk is bad.
Yeah.
Right. Is that what you're talking about?
Well, yeah. And PCs, data center infrastructure, the cloud-based apps that we all have on our phones, whether it's Uber or Twitter, within the enterprise, Workday. And then really the idea of taking that enterprise infrastructure, and today, right now, I'm just talking kind of enterprise and pub sector, but the idea of taking that, what historically was behind a firewall, enterprise infrastructure, only accessible while you're on campus, to bring that into everyday life for the employees, but even more importantly, Darren, is the customers. So as we talk to retailers, as we talk to construction or infrastructure management companies around, how do they improve the customer experience as well?
So it's really kind of extending beyond just your employees accessing infrastructure, you're actually extending that out to the customers even more.
That's right. It's employees as well as the customers. So at Intel, what we're looking at are what are the foundational elements that we could drive through the ecosystem. With one day, what we view as achievable is that every person on Earth, they'll have access to a petaflop of data or petabyte of data, petaflop of compute, all within less than a millisecond access. And so
Wow.
Now it's the laws of physics, the laws of economy, the laws of data sovereignty. Those are the things now we're working on is to make that possible. And that'll give a framework for software companies and cloud companies and all the companies of the world really to create value for their customers.
That's really fascinating because in a recent interview with Glenn Karowski, the CTO of CACI, he talked about that same sort of thing, about that connectivity that connects us all, that allows that sort of thing to happen. And that he sees that coming into space, that the unleashing of the space domain is really going to make that happen. Great example of that, when Elon Musk flew his, Starlink over the Ukraine and kept the Ukraine from going into internet darkness. That was brilliant and showed the power of that new domain that is now available.
Yeah, that idea. Then that brings us in really that second one, which is, all right, if you have this compute, and I threw down really the big goal of a petabyte less than a millisecond away. But if you have that compute, it's got to be connected. And like you said, there's the satellite connectivity, there's 5G and cellular connectivity or 4G, and then there's even the concept of within internet here, within a city, within a state, within a country, of how do you traverse through networks and enable that constant connectivity? Because the pools of compute, if they're not interconnected, the value to humankind just goes down quickly, right?
Yeah. So this should be kind of scary though for people. You talked about data sovereignty in this space. Isn't that a little bit scary for a lot of people and governments that are like, whoa, wait, everyone's connected? And where is their data? Don't I want some protection from my people? How does Intel work through that?
Well, one, first from a technology, but then two, with the governments themselves, understanding the rules, the laws, the concerns. It's one of the reasons why we employ at Intel a pretty sizable force really in countries to help have those conversations with the lawmakers of the countries, in order to create laws that protect the data, but also continue for each of these countries and the businesses in those countries really to foster innovation. But as you know, Darren, oh, sorry. I was just gonna say, like, we don't do anything alone. I mean, it's a team of teams of hundreds of technology companies that are collaborating together on this.
But I think we're kind of the tip of the spear on a lot of this stuff. We're the ones that are bringing consortiums together. Our ecosystem is vast. And I think people pay attention when Intel says, hey, this is important. Estonia was way ahead of everyone else in this digital transformation and protecting their citizens' data, but also unleashing that data and providing more for their citizens at a lower cost and much more effective. You see that same model pervasive throughout the Americas as well?
I don't see that as advanced yet as Estonia.
But do you see it happening?
Well, I think it will. I think it absolutely will, right? I mean, it plays closely into privacy, and that's a space that every government's active around, is protecting the privacy. But then I think a natural evolution from there is exactly what's going on in what Estonia has done. And so I do think it's a natural evolution. The first one's always protect. That's just human beings, right? But then,
Yeah.
the second is actually thinking strategically as a country, as a nation, what to do.
All right, so let's talk outside of the public sector a little bit on
Yeah.
pervasive connectivity. What other use models does this really bring up? When you say pervasive, I'm thinking factories, I'm thinking schools, I'm thinking, see, I go back to my public sector, right? Everything, but I'm also
Yeah.
thinking roads and freeways that are connected. I mean, the list can go long.
I think it's just, yeah, I mean, all of those it is endless, right? But for me on the enterprise side, it's just, and we hit on this earlier, it's the connection of business services with their customers and the extension of that surface that businesses can interact with their customers. And so for retail is a great one. And this concept of really omni-channel retail, where a business, whether I buy from, let's just pick one here in the US, let's say Target, whether I buy from online at Target, in the store at Target, or Walmart or Best Buy, I should name all of our favorite retailers, Kroger. They want one seamless experience for me, where they know who I am, they know my trends, and they know what I need. So then they can recommend additional services in addition. And so this is one where you couldn't do that without this concept of pervasive connectivity. If the only connectivity was I can either shop online from my computer or go in the store. If there was no connecting of the systems there with that pervasive connectivity, that you could see why that experience for me, who I would want, that would break.
So that would be interesting. So if I looked at something online on the Target website,
Mhm.
and when I arrived at the store, it'd say, hey, this is on aisle, what you were looking at is on aisle 5,
Yeah.
bin 6, go
Yeah.
check it out. That'd be kind of cool.
Every retailer, I think, they have their omni-channel strategies. Some are more advanced, but as I travel through the Americas, similar to Mexico, Brazil, the US, Canada, it's a regular topic. But again, like that combines, because all of these superpowers, if you will, build on top of each other. That starts combining the ubiquitous compute, the pervasive connectivity. And then the third one, which we haven't talked through deep yet, but is this idea of, as a company, extending their network from what today would be primarily a data center and cloud, whether on-prem data center or on-prem cloud, public cloud, but then also unifying the edge. And in our Target example, it would be, and I should say again, Walmart, Best Buy, but in those examples, then it's creating a mesh or network that goes all the way through the store.
So in the store, that means point of sale systems, cameras, sensors, weight scales, the whole thing, right?
All of that, right? Yeah, exactly. All with the goal of improving the shopper experience. And so, but then there's also benefits for the stores, which is eliminating loss by having cameras. Like you said, easier checkout for the clients, inventory management, eliminating out of stock automatically, detecting out of stock, traffic flow within the store. So understanding what the traffic flow patterns are, and then being able to place products into the right place. All of those, every one of those, you could imagine, if you're not careful as a business, they could set it up as really a disparate standalone solution, which would be a mistake. What they really want to do is really set up an architecture, an edge to cloud architecture that's almost as if you think kind of one platform, and then they can just layer on top software applications, and that allows a much quicker deployment.
No, I like that. In fact, I was talking to a retailer recently, and their ideas on moving some of this um, edge computing out was to help with spoilage in their produce section. I said, brilliant. And when they were talking about the numbers, which I can't disclose, but when they were talking about the numbers on how much fruit gets thrown out or vegetables get thrown out because of spoilage, it's amazing what the retailers have to do. I mean, because, hey, once it's spoiled, it's spoiled. So if they can do better prediction on when things spoil and look at traffic flow, and with that pervasive connectivity and edge, this is all really changing and being more efficient and more responsible with the resources that we have. That's pretty impressive.
If you enable the team who's stocking the shelves to easily be able to stock what they limes, lemons, seafood when they put it out, and then there's a record of that, and then a digital record of that, you could quickly see how stores then can take different actions to move the product quickly while it's still at its peak, right? And
fascinating use cases there. We've also talked in factory too. There's a lot of things we can do in factories and manufacturing with Industry 4.0, with edge computing. Some great ideas there too. Preventative
maintenance, failure, predicting failures, and then and handling the maintenance. You can imagine even just a company like Intel continuing to digitize our manufacturing, which is, for us, it's a long process, but to be able to have a record of that, know where each processor is by customer and the eventual destination, becomes a huge service for our own customers on the manufacturing side.
All right, hey, the last superpower is AI. I may argue with you, is it really AI or is it more data analytics? So I want you to convince me that it's just really just AI.
Well, I think it is. It's more complex data analytics, I would say. Right?
Okay, there you go. See, you agree with me.
The concept of matrix math and allowing, and I don't know what point the crossover is, but at some point on the number of variables, on the number of data sets where you have to rely on matrix math, I do think there is a crossover there for AI, for sure. But it's something I joke with companies all the time. You can imagine like SaaS. They're saying, hey, great, we've been in the data analytics business for decades, and in the AI business for decades. We just called it data analytics. So,
oh yeah,
but you're exactly right.
So AI. So where do you see this going? The AI space, because AI to me is like this black box of magic, voodoo magic that, data comes in and the AI takes over the world, and we've got Skynet.
Well, I do think it's there's definitely a piece of it's up to the humans to make sure the machines make the right decision, and that there's definitely an ethical element to it. Now, in some of these, they're math equations that can't be solved by humans, which is the promise of AI. And so there is, again, just as we were talking around data, there's elements of ethical AI. There's also elements of really incorporating AI into all applications, which is where you were going, really an extension of today's just data analytics. But to me, I think it's inevitable that this is going to continue to grow. There's just massive amounts of data created every day. It's beyond companies' ability to really compute. It will continue to grow. Even at Intel, we're using it more and more in our own operations.
It's interesting. I just sat in an IDC conference and they talked about the explosion of data. And today we're only looking at 4.5% of the data generated.
That even seems high to me.
Yeah. Can you imagine Yeah, can we imagine with AI algorithms what we might be able to
Yeah,
find other patterns in that data? Maybe the cured cancer is sitting there and we can't unleash it because we don't
it
have our
will.
data in a spot yet that we can use AI to use it.
Yeah, no, it absolutely will. It's and I do think, I mean, some emerging concepts too that'll make it easier, which is um some of the concepts around like enterprise blockchain there. I'm very excited about, and really having a centralized, accessible data sets that through permission base you can get access to. Having the data in the same format is also a big one there, where I mean, so many companies who struggle with their own data, let alone other third-party data sets, in order to do exactly what you just said.
So do you see an emerging kind of data brokerage um, industry forming around these data sets then that can be
I do,
shared?
right? I do, and we've already seen some in market, right, around this. You call it data brokerage, but that's really some of these concepts brought through blockchain, where that centralized data set available via cloud can be accessed by multiple companies, and then there's a ledger of each interaction with that data. To me, it's very powerful, unlocking exactly what you just said, which even cure to cancer. So protecting patients' data, but making it accessible to researchers all over is
Without exposing
that's
data
without
privacy,
exposure.
right?
That's exactly right.
Yeah,
That's
and
exactly,
we've
and
worked on
that's
some
where
of
the
these
power.
architectures. Yeah, these are good architectures that exist today, right?
Yeah. So these are and so I think all four though, right? Is you kind of, again, ubiquitous compute, then the connectivity of it, and then having really a data center to edge strategy, and then also really understanding whether you want to call it data analytics or AI.
Well,
It's what
AI is the
every
buzzword du jour, right? So we're going to use AI.
it is. All right, yeah, sweet. Well, that's what we've been using, but I'm with you, Darren. I think it's more data analytics. But I mean, to me, it's clear. It's all four are key to a digital transformation strategy. One piece we didn't discuss, which I know you're a huge believer and expert on this podcast, is the security
Yeah.
of the data, of the information, of the assets as it moves. And we would be crazy not to spend a few minutes just kind of talking through some of the trends we see there, right?
You know, those trends are really this last COVID kind of exposed a lot of stuff. In some respects, COVID made ubiquitous computing important. I mean, extremely important, right? I need to be able to access my work from anywhere, in the office, at home, you know, wherever. And that really kind of shined a big light on ubiquitous computing and that hybrid workforce that we see happening. And it also exposed our security flaws in the industry as a whole. Huge gaping holes over the last 2 years. Some in the way that we have been architecting networks on security, and then some in our reliability on open source projects and kind of we played this game of security through obfuscation. Well, if I make it confusing enough, no one will figure it out. Well, they did. They figured out some of those things, and we had some major exposure. So I see a huge uptick in the importance and the money being put into security right now. It's incredible, actually, to listen and watch what's going on.
You feel like, Darren, it's our as an industry, you feel like we're on a path to continue. Is the rate of our ability to secure keeping up with the expansion of these four
Uh,
superpowers I said?
um, it has to, especially when you talk about the edge to cloud architectures and the ubiquitous computing, our attack surface has just exploded. We used to say, hey, if I put a nice hard shell around my data center, I'm safe. But all of a sudden, I now have a data center without walls. My data is in the cloud, it's on the edge, it's in the data center, it's everywhere. So how do I secure that data everywhere? That has really made us fundamentally rethink security. So I think, yes, the answer is yes, we can keep up, but it requires rethinking. Rethinking. So things like zero trust, architectures or principles or philosophies, whatever. I mean,
Yeah.
anyone's calling it. So, but I think, yes, I think we can keep up, but it's going to require effort and not just, I'll deal with security later, which a lot of companies have done in the past.
Yeah, I agree. I think it's, and I've been excited around Intel's innovations in the space and some of the things that we've been bringing out around, I mean, from a technology wise, things like the software guard extensions, which is really a safe lockbox of data that a server can, you can run Linux based apps on the data, but that data remains protected from the rest of the system. So some of the work that we've done there is super exciting for our customers.
Yeah, very exciting. And this goes into, Intel's created a lot of really great security features in silicon, and we're building the ecosystem to take advantage of it. And that's the key, right? Because just having the hardware silicon itself doesn't do everything you want it to do. You really need people that know how to use it and that can build new use cases around it, like confidential distributed analytics for cancer research, or multi-domain analytics across, which means across unclassified, classified, and top secret data, where before that data could never mingle. Now we can mingle that data in a protected way and find new ways of solving problems that we couldn't solve before. So very cool stuff.
Yeah, it's one of the things that increasingly, just naturally, as we talk to customers, CIOs, IT directors, CISOs, is just really what we've been doing at a software level, as you said, to really enable these partners to build, these software companies to build around and extract the value from our technologies. We've made huge strides. I think no small part is having Greg Lavender come over. He was at VMware. He's former CTO at Citibank. He really understands the CIO, the app dev, and understands how to make it easier for them to extract the value of the hardware. And a big part of that is our software, the ecosystem of software companies.
Yeah, I love Pat Gelsinger at Vision 2022, right? He said, hey, I used to run one of the biggest software companies in the world, VMware. And we have more software engineers at Intel than we had at VMware. It's like, whoa, I don't think people know that about Intel.
Yeah, it's a crazy way to think of it though, but you can quickly apply, think of that day we let the world know we had 19,000 software engineers. But you could quickly apply them to a lot of projects, and then all of a sudden the 19,000 are fully occupied. Because for us, we operate at 3 layers. One is the foundational software, which is firmware, BIOS, the work we do with virtualization enabling, the work we do with, like, for instance, Red Hat, some of the Linux open source contributions that we make. That first is that foundational level, which is key for security. Is absolutely foundation. And then the second layer, you start thinking through some of the languages and frameworks and the tools and libraries that we create. So like company, for instance, Granular that we acquired, who's really they're absolutely brilliant at really taking existing code and being able to optimize it and get better performance out. But then even things like PyTorch, getting our optimizations into TensorFlow for our standard Xeon processors for AI. all the things that we're doing with SYCL, C++, parallel C++, around one API. So, that's that second layer. And then the third layer, then you start looking at some of the more application level work that we do. And there's hundreds of that. Some of which we never take out of beta. Some we do commercialize, but
and some we just give away.
Usually.
Yeah, in the open source community, which is huge.
Yeah, exactly. I mean, everything from like data center management software to some of the accelerators and some of the tools for OpenVINO. So but you quickly, wow, 19,000 engineers. But then you think about the role that we have to do, that we get to do for the world to really make the compute accessible and safe and secure. You could see why 19,000 engineers are fully occupied.
Yeah, I love how you said that. Safe, secure, and optimized. I think those are our key focus areas on our software endeavors. So, and hopefully more people learn about that so they could take advantage of all the silicon that's there, which is what we want people to do, right?
Well, that's my dream. My dream is like every developer on Earth knows these tools, knows these benefits, because it really does unlock the value of the hardware. And then we were talking earlier around like kind of the moonshot challenge of petabyte of data, petaflop of compute, 1 millisecond away from every person on Earth.
I'll be the first to sign up for that. Give me that right now.
Yeah.
I'll be happy.
It's a developer's dream, right?
Yeah, oh, yeah.
It's like, wow, okay, with that, unlock innovation. So
yeah,
it's that's what we do.
Very cool. Hey, Greg, it's been wonderful again talking to you about the 4 superpowers. Any last words for our listeners out there?
No, I just think, thank you. And I mean, Darren, if they want more information, what do you recommend? What's the one best place to go?
The best place to go is embracingdigital.org. And on there, we've got tons of links from this episode and all of our other episodes into Intel resources so that you can find what you're looking for, whether it's security, ubiquitous compute, pervasive connectivity. I'm going to get them all, AI and edge to cloud. You can find out more information at embracingdigital.org.
I love it. Thank you, Darren, and have a great night.
Hey, thanks. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.